graders, and welcome to lesson 109 on corresponding parts of similar triangles. So the first thing we have to know is that congruent triangles, or incongruent triangles, all corresponding angles and sides are also congruent, which means that they're the same. Whereas in similar triangles, all their corresponding angles are congruent, but not their sides. So, and we can also know that in similar triangles, corresponding sides form ratios. Well, what does all that mean? Let's look at these pictures right here. So here is a pair of congruent triangles. That means that they have three measures that have the same degrees. So whatever angle C is going to correspond to angle Z, and they'll be the same measure. And then we have to figure out which one A corresponds to and which one B corresponds to out of X and Y. And the way that we do that is we're going to do some transformations to ABC and figure out how we can make it look just like this triangle. So the first thing I'm thinking I'm going to do is if I were to rotate it 90 degrees clockwise, like this, it would get it so that way the right angle is on the bottom. And then once I have it there, since I want the right angle on the left side instead of the right side, I would reflect it so that way it was facing this way. And then I would have to translate it to move it right on top of the other one. So let me explain that again. So if we rotated it 90 degrees, it would flip up on its side, and then I could reflect it, and then I would translate it over to there. That was yesterday's lesson. So after a 90-degree rotation, a reflection, and a translation right, ABC would fit on top of XYZ. The vertices that are the same are corresponding. So picturing that, again, if I rotate it, then angle A is on the top. So angle A, once I've rotated it here, even when I reflected it, angle A is going to be this top measure. So that means that the X corresponds with the A. It looks like it would be C and X right now because of the way the triangles are positioned, but once we make them so they're congruent, they would fit on top of each other, we can see that A corresponds to X. So that means that whatever angle A measures, angle X is going to have the exact same measure. Now, when I say a congruent statement, which is when I say this, if I were to write triangle ABC is congruent to triangle XYZ, in this sentence right here, I have paired up all of the letters. Because A comes first here and X comes first here, those two correspond to each other. They're congruent. B is second, Y is second. That means that B and Y would be corresponding to each other, and C and Z would. Remember, these little tick marks I can also use to identify sides. So by doing it this way, I can see that the side length AB, line AB, actually let me pick a different one. Let me pick AC. Let's say line AC. So from here to here, if I went backwards, AC is going to be congruent with line XZ because they're in the same positions. XZ. Let's look at our maps. Does that make sense? Our two pictures here. We have AC with one tick, and then we have XZ with one tick. So yes, those ones are congruent to each other. All right, what we're going to do now, so the vertices that are the same are corresponding, so are the sides. So we're going to find other examples of corresponding parts. I just did one for you. I made sure that it wasn't one of the ones that's down here. So this says angle A corresponds to what? What did we decide angle A corresponds to? Good, X. And we'll write angle X. You tell me what corresponds to angle B. And then here we have BC, that should have a line on top of it. Line BC corresponds to, go ahead and tell me which one it corresponds to. I already gave you an example up here. And then also tell me what AB corresponds to. Here's the next part of this lesson. It says these triangles are congruent. What is the perimeter of each? So I'm given two different congruent triangles with only parts filled in. I have to find the missing part, and then I can add up all of the side lengths. So in order to make this triangle look like that triangle, I would have to rotate it. I could rotate it that way, but then the 4s would be on, oh, does that work? That works. So right now the 4, these two are the same. So the 4 inches is supposed to be on the left side. And if I were to rotate the first triangle 90 degrees counterclockwise, the 4 would be on the left side. So that tells me that these these side lengths are the same, which means that this and this are the same. And this are the same. So now it would be really easy to find the perimeter. I just add them up. 3 inches plus 4 inches plus 5 inches. So 4 plus 5 is 9, and 9 plus 3 is 12, equals 12 inches. Go ahead and do this one on your own. The two triangles below are similar. What is the measure of angle A? Well, what did we learn about similar triangles? We learned that they have the same degree measured as its corresponding angle. So here is my right angle and my right angle. In order to make this look the same, I would rotate 90 degrees clockwise, and then I would have to reflect it. So we can see that this angle, that B, is going to be the same as this 60, and that this tall one, when it's rotated like this, is going to be 30. So what is the measure of angle A? 30 degrees. If I was only given one of these, if I was only given the B, and I needed to solve for A, I would do 60 plus 90. Let me write this out for you just so you know what we're doing. 60 plus 90 plus A, even though we don't know what it is yet. We did because they told us, but if they hadn't told us, like in this problem, you're going to have to do. And then I would say that that equals 180. So I would add up 60 and 90, and then I would subtract them from 180, the way that we solve our equations, and we would get A equals 30. Go ahead and apply that right here, and I put a little note for you on the bottom, reminding you that all of the angles in a triangle add up to 180 degrees, like I just showed you right there. Go ahead and get to work.